Join us as we explore the fascinating world of artificial intelligence and understand how it works. Artificial intelligence is the foundation of modern technology, inspired by how our brains work. Let's start by understanding what artificial intelligence actually is. Artificial intelligence is a computational model that's inspired by the way biological neural networks work in animal brains. It consists of interconnected nodes that we call neurons or units, which process and transmit information. Most importantly, artificial intelligence can learn complex patterns by training on large amounts of data. Here's a single artificial neuron. It takes multiple inputs, multiplies them by weights, sums them up, and applies an activation function to produce an output. Now let's look at the basic structure of artificial intelligence. Artificial intelligence is organized in layers of neurons. The basic structure flows from an input layer through one or more hidden layers to an output layer. This is a simple artificial neural network with 3 inputs, one hidden layer with 4 neurons, and one output. Each connection represents a weighted link between neurons. Let's understand how information flows through artificial intelligence. The process of information flowing through the network is called forward propagation. First, input data enters the input layer neurons. Each neuron computes its output by taking the weighted sum of its inputs and applying an activation function. Mathematically, this is expressed as y equals f of the sum of weighted inputs plus a bias term. This process continues layer by layer until we reach the final output. Here's an example showing how numerical values flow through the network. Input values 2, 1, and 3 are processed to produce intermediate values in the hidden layer, which finally result in an output of 0.7. Activation functions are crucial components that introduce nonlinearity. Let's look at some common activation functions used in artificial intelligence. The sigmoid function squashes values between 0 and 1, making it useful for binary classification. ReLU, or rectified linear unit, is simple but effective. It outputs the input if positive, otherwise 0. Here you can see the shapes of sigmoid and ReLU activation functions. These nonlinear functions allow artificial intelligence to learn complex patterns. Artificial intelligence has countless applications in the modern world. Artificial intelligence excels at image recognition, identifying objects, faces, and scenes in photographs. It's also used in natural language processing for translation, chatbots, and text analysis. Recommendation systems use artificial intelligence to suggest movies, products, or content based on your preferences. In healthcare, it helps analyze medical images and assist in diagnosis. Let's summarize what we've learned about artificial intelligence. Artificial intelligence is a computational model inspired by how the brain processes information. It consists of layers of interconnected artificial neurons that process data. Most importantly, artificial intelligence can learn complex patterns by training on large amounts of data. Today, artificial intelligence powers many AI applications that we interact with every day, from search engines to virtual assistants.